Hi guys, so we're here to learn a little bit about probability. I put it in the Google Classroom, but I just wanted to reiterate. So we are going to be in chapter 10. The chapter 10 in our new Big Ideas Algebra 2 book is actually the same chapter they put in your geometry book. So instead of having you do the exact same problems you did last year in geometry, I'm going to run off a PDF of that other textbook that I've used that we started to have a big packet before this all went down. But just so you know, kind of have the same type of section. So I also attached in Google Classroom a PDF form for the notes. You could have printed that off, you didn't have to, but these notes will kind of follow along with that. So, what you did right before we had our quote unquote spring break is you were working on sample space. Sample space is a way to get how many outcomes or how many different possibilities there are. One thing you might have noticed is hey, we need to find a way to really organize so we're not duplicating things, so we're not missing anything. So when we count tasks, we need to organize information. And some ways that we have to count, and if you've looked at that PDF of chapter 10 already, maybe you've seen, oh, there's lots of different ways. We can make a picture. We can list the items. And when we list, we want to make sure we kind of go about it in an organized fashion. We can make a table. And then something that may be a little unfamiliar, something called a tree diagram, which we'll go over. And that's just a way to kind of organize. And again, we'll talk about this in other chapters or other sections, but this is going to help us with sample space, and that's possible outcomes for an event or a situation. So you might want to add that to your notes if you're writing this down. If you're just listening, that's up to you. Let me tell you, this is weird having to teach this without getting feedback and kind of pace. So hopefully I'm not too boring. I'll try not to drag on too much. All right, so let's go to the next screen here. We're going to jump right into a problem, and this is part of the reason I had that PDF for you so you don't have to write it all down. But this is going to be a good problem to do one of those tree diagrams with. So it says snowboarding. A sporting goods store offers 3 types of snowboards, all mountain, freestyle, carving, and 2 types of boots, soft and hybrid. How many choices does a store offer for snowboarding equipment? Well, there's not a lot of choices here, and so it's really easy, or you probably could make a pretty organized list. But another way to do it is to say, okay, for choice number 1, and you don't have to label it here, but I'm just kind of helping you see how we can get it set up. You could have the all mountain, you could have the freestyle, and let me get rid of this, and let me get rid of that too. And you could have the carving. So that's 1 choice, 2 choices, or 3 choices. After you choose all mountain, you can choose 2 different types of boot. You could do the soft or the hybrid. So this is for choice number 2. And then same thing for this one, same thing for this one. And so all your possibilities, you kind of read this side to side. You say you could go mountain and soft, mountain and hard, hybrid. You could go freestyle and soft, freestyle and hybrid, carving and soft. And so when I count up my choices, I count this as 1, 2, 3, 4, 5, 6. There are 6 different ways they could use those things or those combinations. And so that's a way to do a tree diagram. Let's do it for another situation. There are 3 light switches on the wall. How many different combinations are there for the light switch? So we're going to have switch 1, 2, and 3. The first switch could be on or off. Can't really use O for both of those. The second switch then could be on or off. And space this out very well with my numbers up here. But then for that, I could have on and off. For this one, I could have on and off. For this one, I could go on and off, on and off, on and off. You get the idea. If I needed to count or actually list all the ways, I'd say on, off, on. You get the idea. If I just need a total, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 ways. And if you're doing a problem and it asks you to list, you can just give me the tree diagram if that's how you're deciding to organize. You don't then have to go and actually list by saying on, like I just did a second ago. So those are two examples of a tree diagram. Then we're going to move on to the fundamental counting principle. So the fundamental counting principle says there are two events. If one event occurs in m ways and the other or the second event occurs in n ways, then the number of ways for them to combine is m times n. That's what you're filling in there, and it's m times n. You might even want to put it with a little dot. You're multiplying those. If you have 3 or more events, that can be extended and you just multiply those. So for 3, you do m times n times p. If you had 4, you just multiply that fourth one in there. So those are for 2 different events, 3 different events, and you're looking at each of those. So like if I go back to this light switch, the first light switch could be on or off. That's 2 options. The second one could be on or off, 2 options. The third one could be on or off. I multiply all those. That's a way I could get 8. I would like to use that unless I'm asked to list or count or show all the ways. If I just actually need a number, I can use this fundamental counting principle. And that's the key there, is you multiply the number of ways. All right, so you filled in this blank, and I would maybe add that to your notes there. You multiply the number of ways. That's for that fundamental counting principle. All right, so we're moving on here. So you are framing a picture. The frames are available in 12 different styles. Each style is available in 55 different colors. You also want a blue mat, which comes in 11 different shades of blue. So what I do is I use blanks here. So I have 3 different things I'm picking. I'm picking 12 styles, 55 colors, and then 11 mats, and I multiply those. And I've got that number right here for us. When you multiply those, you get 7,260. I like to put ways on there. If you forget, that's okay. Ways or combination work. Let's go to this next example here. The standard configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. How many different license plates are possible if the letters and digits are repeated? And that's going to be something we come back to over and over again, repeats and non-repeats. Well, we got to know how many letters in our alphabet and how many digits in the number system. So letters, hopefully we know there are 26. So I've got 26 here, followed by 2 digits. Digits can be 1, 2, 3, 4, 5, 6, 7, 8, 9, but it can also be 0. So there's actually 10 digits. And I can repeat them. So if I use 5 here, I can use 5 again. So I still have 10 digits to choose from. And then I've got 3 more letters that I can repeat. Man, this is going to be a big number, and you're going to get some big numbers when you do these problems, really in this whole chapter. So this is 45,006,097 or 697,600 ways. Now let's tweak that a little bit. If they cannot, neither the letters or the digits can be repeated. Let's see, we had 6 spots there, 1, 2, 3, 4, 5, 6. So the first one was a letter. These 3 were letters, but I can't be repeated. So if I use A, now I'm down to just 25 letters. Now I've used A and B. Now I'm just down to 24. It doesn't matter which letters, you're taking 1 out of that set. And so that would be 23. Start off with 10 digits. I've picked 1 digit, that's out of the pile. And so now I only have 9 digits. When I multiply all those, significantly less, 32,292,000. Need 1 more 0. Ways. Again, we're multiplying all of those out. And then this next one here, at a blood drive, blood can be labeled typo here, surprise, surprise, still making mistakes, of 4 types, A, B, AB, or O, and 1 of 2 Rh factors, positive or negative, and 1 of 2 genders, female or male. How many different ways can blood be labeled? Well, there are 4 types, there are 2 Rh factors, and there are 2 genders. We're going to multiply those. We get 16 ways. All right, I'm going to take a little break there and tell you if you want to even take a little break and let all this soak in, you might want to go ahead and start the first part of this section's assignment, which is in that PDF form. You can print it off, you don't have to, but you're going to look for page 686. This is in section 10.1, again, in the PDF, not in your book. And you're going to do 3 through 15 odd, and you're going to do that on notebook paper. Again, make sure you see the difference between list and whether you're just going to get on there and you're going to say the ways. If you're using the ways, how many, that's when you're going to use the counting principle. If I ask you to list, that's where you're going to have to actually list them out, use a tree diagram, things of that nature. All right, I'll have a second video up for you when you're ready to start the next part of the assignment.